Hi, hello, good evening. Welcome back to Infinity Online Academy. Right, from the last session, so we are discussing about reflection of light at a curved surface areas. Okay, so now last small topic is remaining magnification values. Okay, magnification values. So this magnification formula already we discussed. What is this? M is equals to Hi by HO is equals to minus V by U. Okay, minus V by U. This is a formula. Okay now. So based on this formula, if magnification values M, magnification represented with the symbol M, M is greater than 1. Okay now, M is greater than 1. So what is the characteristics of image is going to be formed? Okay now. So if M is greater than 1, magnified image is going to be formed. Means enlarged image. Object size, if you will compare object size and image size is greater than the object size. Okay. So M is greater than 1, then magnified image is going to be formed. Next, M is less than 1. M is less than 1. M is less than 1, then we are going to get the diminished image. Diminished image. Object height, image height, if you will compare, object height is greater than the image height. So means indirectly image height is small. Image height is small. Diminished image is going to be formed. Okay. Remember these values. These are the very important information. Okay now, next M is equals to 1. M is equals to 1. Same size image is going to be formed. Same size. There is no changes between size of the object and size of the image. Same size image is going to be formed. So when M is equals to 1 value. M is equals to 1. Okay. Next, right here, one more important information. M is magnification value. Magnification value. So we are going to get positive. We are going to get a positive. So then characteristics of the image is virtual. Okay now, one more important characteristic, by observing the magnification value, if M value is positive, then virtual image is going to be formed. Okay now, right. Next, if M is a negative, M values, magnification values are negative, then real image we are going to get. This is a main two important concepts, important characteristics by observing the magnification value. Okay na, clear? Right here. So if M value is positive M values, convex mirror. M value is positive, convex mirror. Next, if M value is negative, then it is a concave mirror. Okay now, for example question, how they will form? If M value is positive, what is the mirror? Mirror they used. Okay now, if it is positive, convex. If it is negative, concave. Okay, clear? Right, this is a magnification values. Very important concepts. Once again I will revise it. So M greater than 1, magnified image. M less than 1, diminished image. M equal to 1, same size image. If M is a positive value, virtual image, and it is a convex mirror. And M value is negative and it's a real image. And what mirror we are using? So concave mirror we are using. Okay na? So these are the important concepts. Okay, so listen carefully. Examiner is going to form and he is going to touch the each and every corner of the chapter. Okay na? So don't leave any single point. So each and every point is very important. Okay, so these are the complete information. Now, okay, so we are going to see the questions, model questions. Okay, so let's see here model questions, how the examiner is going to be form questions. First, see here, First question. See the first question. The midpoint of a mirror is known as. Midpoint of a mirror is known as. Tell me, what is the midpoint of a mirror is known as? Okay, tell me. It's a focus, pole, center of curvature, midpoint. See here, the midpoint of a mirror is known as a. First, we will discuss about what are the main options they given in the question. Observe it: focus, pole, center of the curvature, midpoint. So, in these three options, first, if you will follow the elimination method, so this is a first you will eliminate midpoint. In the discussion of the reflection of light, if you discussed the midpoint of a mirror is known as a midpoint. First elimination. Okay na? So we discussed about pole, we discussed about focal length, we discussed about focus, we discussed about radius, and we discussed about center of curvature, and we discussed about principal axis, curved surface area, spherical mirror, but midpoint. Okay, so meaningless. Right here. Next, center of the curvature. Okay, if you will take center of the curvature, what is the center of the curvature? For example, this is a spherical mirror. Okay, this is a spherical mirror. So this spherical mirror and this curved mirror. For example, what are the mirror here? Curved mirror. If you are taking, that is cutted from the spherical part of the mirror. So this spherical mirror is center point is known as a center of curvature. Okay na? The spherical mirror center point is called a center of curvature. So this is also not. Next, focus. If you will observe the focus, so then focus is also wrong. Why? Because so focus on this curved surface area, of a concave or convex. That parallel beam of light is going to be incident on it. After that all parallel beam of light is going to be focused at one particular point. That is called a focus. But here, midpoint of a mirror is known as a focus. No, wrong. So right here, pole is the correct answer. Geometric center of a curved mirror is known as a pole. Okay, is known as a pole. So option B is the correct answer. So next, second question. See the second question. Read the second question first. If object is placed at C on the principal axis in front of the concave mirror, the position of the object, the position of the image is image. Okay na? Image is. See here. First, if you will observe options, infinity, between F and C, at C, beyond C. Okay na? Object, where is the first you have to concentrate the question. Object where is taken on the principal axis. On the principal axis, object is taken at C. Object is at C on the principal axis. Next, what is asking? Position of the image. Okay, right. So these all here, object is placed in front of the concave mirror. Right here, so I will draw the concave mirror. Outer surface area polished, reflection test, inward surface area, and this curved surface area is also have center point. That is curved mirror center point, pole, from the last question, right? So principal axis, that line is joined from the pole and center of curvature, and if you will draw the half of the distance of the radius is called focus, or parallel beam of light where it is going to be focused at one particular point on the principal axis, that is also called focus here. Now object, where is placing object? On the principal axis, right here on the principal axis object is placed. For these object, where image is going to be formed? Okay, right? So we will follow the two ray diagrams. By following the ray diagrams, we are going to draw the its object diagram. First, one ray passes parallel to the principal axis. Right, after that, reflected ray will passes through the focus. Okay, next one more ray. Here I am taking that ray passing through the focus, and after that reflection, it passing parallel to the principal axis. Right here, next, right, on C, image is also going to be formed here. Image is also going to form on the C. At C, image is going to be formed. Observe here, what is asked? If object is placed at C on the principal axis of a concave mirror, position of the image is where image is formed? C. First, infinity. No, infinity when it will forms? If object is placed on focus, image is also going to be formed at infinity. Between F and C. If object is placed behind the center of curvature, image is also going to be formed between F and C. It is also not. Next, okay, so beyond C, when it will be formed, object we will take between F and center of curvature, image is also going to be formed at beyond center of curvature. But here correct option, center at C. Okay, now where you are going to take the object at that position downward, image is also going to be formed, and inverted image, same size image, and real image, and at C, 4 characteristics. Clear? So this is about a second question. Now if you will observe third question, observe here, all the distances related to the spherical mirror will be measured from, right, sorry, all the distances should be measured from, okay, mirror, any spherical mirror, all distances. Tell me, right? So in the last session we discussed this sign conventions. Okay, now based on the sign conventions, you have to answer. You are going to answer to this question. First sign convention. First, what we discussed, sign conventions. Sign conventions. All distances should be measured from its pole. All distances should be measured from the pole. Option, observe here. First option, object to image. There is no meaning object to image, and focus of the mirror, not, and pole of the mirror is correct answer. Pole of the mirror, image to the object, this is also wrong option. So answer, what it is, all distances should be measured from the pole. Okay, now what are the, if you are going to be measure object distance or image distance, or remaining the only this image and object, that all distances should be measured from the pole point. Okay, now, so clear? So this is the third question. So next question, if you will observe, so say see here, which of the following represents magnification m? Okay na? So in the four options, in these four options, option 1, 2, Roman number 1, 2, 3, 4. So in this, which one is represents magnification m value? Magnification m value. Right? Already you know formula. What is a m? Magnification is represented with the symbol m is equals to hi by ho is equals to minus v by u. Okay na? So what is the formula? M formula, magnification formula. Magnification m is equals to hi by ho, height of the image by height of the object is equals to minus v by u. This is the formula you are going to use. Observe here. So here multiple options answer is given. Okay na? So v square, this is a v square by u. Okay na? So v square by u. Here option v by u. Wrong. Next, minus v by u. Yeah, right. This is a minus v by u also correct. Next, hi by ho. Hi by ho is also correct. Next, ho by hi wrong. So two options are correct. Option number 2, option number 3. These two are correct. Once observe here. In the options 1 and 2, okay na? So 1 and 2 wrong, 2 and 3 correct, 3 and 4, 4 and 1 wrong. First, so you have to choose B option, that is the second and third. Then that is a formula, magnification m is equals to hi by ho is equals to minus v by u. Okay, so next question. So next question, see here, we get virtual image in concave mirror when object is placed. Okay, question is asking, okay na, object is placed at one particular position when we are going to get a virtual image, when we are going to get a virtual image. See here, first, so virtual images characteristics, places, if you will observe. Okay na? Virtual image characteristics, if you will observe. So object, for example, in front of the concave, right, draw the concave lens, mirror, center, pole point, center of curvature, focus. Right, if you will take the object between F and P, focus and pole, parallel ray, and after incident it passing through the focus, and one more ray, here it is passing through the center of the curvature, and it can't deviate. So the two reflected rays extended lines are going to be meet at a backside of the concave mirror. Right here, enlarged image, enlarged image, and a virtual image, and a enlarged virtual behind the mirror, and so one more erected image is also going to be found. Here what is asked? Virtual. Okay na? Virtual. So at focus is the first option. At focus is wrong. Between pole and focus. Between pole and focus is the correct answer. On C same size. On C same size and it's a real image. It's a real. Okay na? Beyond C also real. Okay, beyond C also real. Observe here, at focus, if you will place the object at focus, image is also going to be formed at infinity. We don't know that. So you can't tell what is it is a virtual. Okay na? But sometimes it is a option they give, but virtual. So but here virtual image is also going to be formed between pole and focus. So at F infinity position image is also going to be formed. Okay na? Clear? So the next question. Okay, right. Sixth question. Observe here. Read the sixth question. The minimum distance from the real object to a real image. Okay na? Minimum distance to the real object and a real image in a concave mirror. Very important question. Okay na? Very interesting question also. If you will observe, so real image and real image, and he is asking the distance, minimum distance is between the real image and a real object. So if you will take a concave mirror, so in front of the concave mirror, object is placed for particular position. I will explain it. See here, focus and center of curvature. Okay na? So you know that minimum distance. Object, if you will take behind center of curvature, image is also going to be formed here between F and C. If you will take object at infinity position, image is also going to be formed at focus. And then if you will observe, at infinity image is also formed focus. Now measure the distance. Here you are going to get the distance d1. Okay, first I am taking d1 distance. Next, if object is at behind center of curvature and image is also formed at between F and C, that is I am taking distance d2. Now object I am going to take here on center of curvature. Image is also formed on center of curvature. At center of curvature, image is also going to be. Now this is a real object and it is also real image. Why? Because reflected rays direct intersecting image is also going to be formed. This is also real image. Real object. Sorry, image, real object. Measure the distance between the object and image. Then what it will be? So I am taking d3. Okay na? Observe here, d1 is a long distance between the object and image, and here also d2 is also object. It has some distance between the object and image. If you will observe, real image and real object distance is above the principal axis, below the principal axis, at same particular position on the C. Objects are there. Object is there. Image is there. Then the distance between the image and object is 0. So then minimum distance is 0. Minimum distance is 0. Okay. So 2f is the 2 into f. 2 into focal length. What it is? Nothing but it is a radius. It has some distance. F is a focal length. F by 2. Half of the focal length. So these are all wrong option. So what it is? Minimum distance is 0. Clear? That next question. Seventh question. Once read the question carefully. Size of image formed by a convex mirror is always, okay na, size of the image formed by a convex mirror always, okay. So object diagrams of a convex mirror, you discussed about if any place in front of the convex mirror, if you place object in front of the convex mirror, wherever, image size always diminished. Image size is always diminished. Always erected image you are going to get. Always virtual image you are going to get. Okay na? So always it is behind the mirror. Between F and P. Between F and P you are going to get the image. So now tell me, size always, but enlarged? Wrong. And diminished is the correct answer. Equal size, no. How it will be? So only on center of curvature there is no possibility to keep the object equal size. So depend on the position of the object is also not depend. It's not depends on the position of the object in front of the convex. Wherever you will keep, always diminished, always virtual, always erected. So always it will forms between F and P. Focus on the pole. Clear? Right? Next question. An object is placed, next question, an object is placed at certain distance on the principal axis of a concave mirror. The image is formed at a distance of 30 centimeters from the mirror. Find the distance of the object. Okay, now find the object distance if radius of the curvature R is equals to 30 centimeters. Okay, now object is placed at a certain distance on the principal axis in front of the concave mirror. The image is formed at a distance 30 centimeters from the mirror. So find the object distance if the radius of the curvature is 30 centimeters. Okay, na 30 centimeters. So I will take here diagram. Once see here, based on the information. Observe here, I will take the diagram. So principal axis question is missing. Okay, so right, see here. So now, what it is? What's a mirror? Yeah, concave mirror. Right, concave mirror. Outer surface area, bulged surface area is going to be polished. Pole, principal axis, focus, and center of curvature. Okay, now here radius of the curvature. These curved portions, radius is, what is the distance? This distance are radius are, yeah, R, it's a radius. Then object distance if the radius of a curvature R is equals to 30 centimeters means from the pole at 30 centimeter distance object is placed. Okay, right. Next here, observe, an object is placed at a certain distance on the principal axis of a concave mirror. The image is formed at a distance of 30 centimeters. Object image is also formed on the 30 centimeters. So clear? Why? Because on center of curvature same distance image is also going to be formed. Okay, na? Right. Next, find the object distance. Okay, na? Find the object distance. Where image is formed? 30 centimeter. Okay, na? Image is formed 30 centimeter. Okay. So, right. Image is formed at a distance 30 centimeter. Right, radius of the curvature is also 30 centimeter. So radius indirectly downward object distance image distance, radius of the curvature equal. Okay na, r value, radius of the curvature, image distance equal is nothing but object is placed on the center of curvature. So then what is the distance between the object and pole? 30 centimeters. It's a C is the correct answer. Okay, so 15 centimeter, so radius is taken 30. Then if you will ask find f, then that is also focal point. The focus is also called 15 centimeters. But option, what is asking? Find the distance of the object. Find the distance of the object. Okay, so then distance of the object is 30 centimeters. So 15 is also wrong, 10 is also wrong, 7.5 is also wrong from this question. So, right, so next question. Second question, right, ninth question. Okay, see here, observe carefully. Next question, once read the question. We get a diminished image with a concave mirror when the object is placed. When we are going to place at one particular place on the concave mirror, in front of the concave mirror, when we are going to get the diminished image. Okay now, right. So by now we are going to follow by observing the focus. First option, at focus. If you will place the object, infinity place, image is also going to be formed. It's a wrong. Between pole and focus. So between pole and focus, if you will place the object, see here, right, already so in the red object diagrams we observed that focus, center of curvature, right, between pole and focus, here, middle, in the middle you have to take. Here, ray diagrams, parallel ray, after reflection passing through the focus, and one more ray you are going to take here. So it is passing through the center of the curvature, right? It's a two rays extended lines you are going to draw. It's going to be made behind the mirror. Okay, now it's going to be formed behind the mirror, right? Here enlarged image you are going to get. But so what is asking in the question? Diminished. So it is also wrong option. Means we don't want that. We have to eliminate it. Next, at C. So at C, object size and image sizes are equal. But here he is asking diminished. Then it is also, you have to eliminate it. So next, beyond C. Observe the ray diagram for behind C. If you will take the object right here we are going to draw. See here, object is placed here, ray diagram, after passing through the focus, then one more ray passing through the focus, after it will be parallel, image is also going to be formed here. Observe here, if object is placed beyond C, image will formed between F and C, so then here you are going to get the characteristics, the diminished type of image, small image you are going to get. So option beyond C is the correct answer. Option D is the correct. So next question. See here. So the ray, 10th question, the ray which passes through focus of a convex mirror and it strikes it, then it path of the reflected ray. Ray diagrams. Okay na? From the ray diagrams of a convex is asking the question. Ray that is passing, okay na, the ray It appears, it passing through the focus. It passing through the focus, and it is passing through the and it is going to be incident on the convex mirror. Then reflected ray will appears. Reflected ray will appears parallel to the principal axis. Okay, now after reflection, the reflected ray will passes parallel to the focus. Okay, parallel to the principal axis, right here. Parallel to the principal axis. First option is correct answer. Along the same path? No. Along the same path? When it will be? If ray appears, it is passing through the center of the curvature or principal axis. That is all. Next, through F. It's not. If incident ray is passing through the focus, then reflected rays also appears on the same path? No. Then C. Center of curvature undeviated, it's in which direction it will be incident, on the same path it will be bouncing back. Okay, that is also the wrong option. So option A is the correct answer. Okay, next question. Okay, next question we'll see. Right here, see, the radius of the curvature of a concave mirror is 30 centimeters. Then focal length of the mirror is, okay, you have to use the formula. First, when you are reading this question in your brain, you have it will be you have to remember the formula to find the focal length, to find the focal length of a lens or focal length of a mirror. You have to use the formula. What is the formula? F is equals to R by 2. Okay, na? R by 2. Radius by 2. Radius of a curvature of a concave mirror is 30 centimeters. So then focal length F is equals to 30 divided by 2. So 2, you have to divide it. 2 ones are, 2 ones are. Remainder 1, so it will become 10. So 2 5s are 10. So finally F value you are going to get 15 centimeters. 15 centimeter. So once check the options. 30 centimeters wrong, 15 centimeter, 60 centimeter, 75 centimeter. So option B is the correct answer. Okay, na? So you have to remember the formula. Or radius is equals to 2 into F, reverse, or F is equals to R by 2, half of the radius. Okay, so next question. What is the image position of the object in the given ray diagram? So okay, actually it's for missed. Ray diagram is missed. So if you will take ray diagram is missed here. Later we'll discuss. So 13th question. So dentists uses to observe the teeth. Okay, now. So in the content explanation time, I said one mirror is called a doctor's mirror. What is a mirror? Concave mirror. So concave mirror is called a doctor's mirror. So lenses, first you have to eliminate this. Okay, na? Eliminate this option. Lens, wrong answer. Option B, wrong. Okay, you have to eliminate it. Next, second one, plane mirror. What we are discussing? So plane mirror, you are going to observe the same size of the object and same size of the image. So there is no difference right here. So there are two, convex and concave. So convex is used for only specially diminished images. But here you have, if doctor he will use convex, then the teeth inside the teeth are decay. It is observing the small size. Then how he will identify the defect? Okay, problem. Then he will use the concave mirror. Option A is the correct answer. Okay, clear? So the next question. These are the top questions, beta. most important questions. Previously, the examiner asked these questions. Okay, here. Actually, these fractions are different here. Means f by 2. Here option you have to write it as a. So I will explain. See here. Option R is equals to f by 2. Here f is equals to R by 2. Okay, these are the options. Change it. Options are changed. So the relation between the focal length and radius of the curvature of a spherical mirror given by. Okay, now relation between the focus and the focal length and the radius. Right, already what we discussed in the last problem. R is equals to 2 into focal length. 2 into focal length. Or so you are going to observe focal length f is equals to R by 2, radius by 2. These are the relationship between the focal length and the radius of the curvature. So options, once observe the options. So f focal length is equals to 2 into radius. 2 into radius, wrong. So R is equals to f by 2. Half of the radius. Focal length is half of the radius, but is given in the reverse. It is also not. So f is half of the radius. Correct answer. So f is equals to R, wrong. So option C is the correct answer for this question. Relationship between the focal length and radius is R is half of the focal length is half of the radius, or radius is 2 times of the focal length. Clear? Right. Next question. 15th question. So here also same. Right, here we will write HI. Options once change it. HI by HO is equals to V by U. First option. Second option, HI by HO. HI by HO is equals to U by V. Next, third option, HI by HO is equals to minus V by U. Next here, so fraction of HI by HO is equals to minus U by V. These are the options. This is option A, B, C, D. Observe here. Question, once read the question. Magnification of spherical mirror. Directly he is asking mirror magnification formula. M is equals to. So then M magnification is equals to HI by HO is equals to minus V by U. Okay, now this is the formula. Right here, options observe here. HI by HO is equals to V by U. Minus is missed. So option A is also wrong. B, HI by HO is equals to U by V. This is B is also wrong. Next C, HI by HO is equals to minus V by U. So option C is the correct. Option C is correct. So D is also given. Once observe here, minus U by V. Minus U by V is also wrong. Okay, na? So by observing the options, only it's matching option C. That's why you have to choose option C. So next. Okay, na? Next question. Read the next question. When parallel rays are incident on a concave mirror, after reflection they meet. Here, what we are going to observe? So, parallel beam of light, parallel rays are going to be incident on concave surface area, concave mirror. Okay, na? So, they are going to be converged at one particular place. Where? At focus. Option. By reading the question, you are going to answer for this type of questions. By reading the question, you are going to answer directly. If rays are coming parallel, all parallel beam of light is going to be focused at a focus. Their reflector rays are going to be meeting at one particular point on the focus, on the principal axis, that is called a focus. Okay, So right, next next question, see here. Let's see. 17th question. The image which is formed by a extending rays of a backwards is, right, already we discussed that. Reflected rays direct intersecting real. Reflected rays extended lines are forming the image, that is virtual. Okay. So first observe the options. Real. Okay now. It's real or no? Option A, you have to eliminate it. Eliminate. Next. So virtual. So okay, right. There is a possibility virtual. Next, here one more characteristic also given. Characteristic. Erect. So we'll see here. C also we will observe. So first we will eliminate a real. It is also wrong. Next, virtual inverted. Alright, option B and D are, there is a possibility to correct. Next, one more characteristic you have to observe. When virtual image is formed, it is always erected. It always erected. So it is not inverted. So that's why you have to eliminate the option D. So option B is the correct answer. So it's a virtual and erected image is also going to be formed in the case of when rays are going to be made backward of the concave, backward of the mirror. Okay, extending lines. Right, next. So one more, next question. Okay, mirror formula. So mirror formula options are given in the different. So right, I will write the options first. A. So option A, one see here. Option first. So 1 by F is equals to 1 by U minus 1 by V. Option A. Option B, 1 by F is equals to 1 by V plus 1 by U. C, option 1 by F is equals to 1 by U minus 1 by R. And the next last one, 1 by F is equals to 1 by V is equals to 1 by U. Okay, this is option D. Observe the option mirror formula. What is a mirror formula? I think it is struck in your brain. 1 by F is equals to 1 by U plus 1 by V. So if it is first option, minus is given. Eliminate it. 1 by F, 1 by V, 1 by U. 1 by U, R is not correct. Cut it. And the next 2 equals are given. This is also D also wrong option. So option B, 1 by F is equals to 1 by V plus 1 by U, or 1 by F is equals to 1 by U plus 1 by V is also correct for the mirror formula. So next question. When reflected rays are converge, dash image is formed. Reflected rays converging means, for example, right here I will draw. See here, this is a one reflected ray and this is also one reflected ray. So these two rays are going to be converge, means they are going to be meet at one particular point. If you will extend, right, observe here. Here it is meeting. Reflected rays are direct intersecting. So then which type of image is going to be formed? Real image. So option real and okay, 2 options are given. One more. Real. Okay now, when erected image is also going to be formed? If it is given erected, compulsory it is a virtual. But here is given real. So option B you have to eliminate. Virtual and inverted is also wrong answer. Virtual and erect is also wrong answer. So then you have to choose option A is the correct answer. Okay now. Right, next last question. Wait. Right, last question. See here. When an object is placed at F, object is placed at F, object is placed at F, the image can be formed on. Where is the object? At F point, at focus point. Where image will forms? Where image will forms? So at infinity. Okay na? If object is placed at infinity, image will form at focus. If object is placed at F, image will form at infinity. So this is a infinity answer. So once again, so welcome to Infinity Online Academy. Right here, answers, observe here, answers from these options A, B, C. So pole is given, option, wrong option, focus, wrong, center of the curvature is also wrong. So at infinity, image you are going to get. Okay na? Right? So I think, so 20 questions, you observe that how the examiner is forming the questions. Okay na? So once observe this all questions and try to answer the question before explanation. So you have to answer by yourself, and after explanation you have to assess it whether it is correct or not. Okay, right? So in the next session, again next session we'll meet with the another topic, refraction of light at curved surface areas. So thank you.